So our special guest here that we have, who is not a Cherry employee, is Steve Pressman from Alpine Cyber Solutions, and he is here to talk about data protection.
All right. So I'm that guy that you have to listen to, but you don't really want to, the security side of things. Nobody likes security. But I'm going to do my best to at least show you the value and show you the pitfalls and where you could go wrong and how you could be right. I've got like 25 slides in 20 minutes. I don't like talking that fast. I might have to zoom through some things, but please come and ask me questions later or ask questions at the end. Keith is after me, and he's worth the wait, so I'll make sure I don't go over. So a little bit about me. I have a background in the defense industry. I come from Lockheed Martin, spent 10 years there. Spent 2 years spinning off a company from there and then decided I like doing my own thing better. So I ended up with my business partner creating Alpine Cyber Solutions. We focus in cloud, we focus in cyber. We didn't realize at the time that we created the company that it would be such a great combination, and it really ended up being fortuitous for us. And this is an area that's burgeoning, really. And everybody needs both of those things, so here we sit. I have those certs up there, and I do know my stuff. Not that that means I know my stuff. I'm just saying that in addition to that, anyone can take a test and get a piece of paper. And this is what I look like when I'm not here, and my family. So let's talk about some of the basics. I'm going to try to take you through a mile wide and an inch deep of the security components that you need to worry about. I am not focused entirely on IoT in this presentation. I'm talking in general data stored at AWS. When you're leveraging IoT, as you've heard throughout all of the other great presentations today, you have tons of options once you get to the server side as to how you store your things and where you put them. They all need to be secured in their own ways, and it's as varied in how to secure them as it is the places that you can store them. So, the basics, the shared responsibility model. If you've ever gone to any sort of security-related topic related to cloud or AWS in general, or AWS in specific, you know about the shared responsibility model. What this means is there is an area, there is a line under which AWS is responsible for the securing of your data. That's generally things like the infrastructure layer, that's the physical, that's the up into the hypervisor, and then you get into the, well, it depends. If you're working with infrastructure as a service where you're getting an EC2 instance and you're storing, you're running your own stuff on instances, once you get into that OS, AWS is absolved of all responsibility and you're above the line, and the customer is responsible for making sure that the things you put in the cloud are secure. The way it's generally said is AWS is responsible for the security of the cloud, and you're responsible for the security in the cloud. Okay? So you can't just say, well, and I don't hear this too much anymore, well, I put it in the cloud. I thought they were going to keep it safe. That's naive. It's not the way it is. Okay, now, data storage options. There are a lot, and this is not even a full list. If you're talking about in terms of, and I couldn't find a better word than traditional, in reality, object and file-based storage, you have a lot of different ways to handle that. In fact, I'm working with 2 different companies right now who are small and they want to back up their data to AWS. And I could easily see saying, all right, we have a solution that leverages S3, and we store your data up there, and we archive it off, and it goes into Glacier, and it becomes, a life cycle. I could see throwing a snowball at them and saying, you've got so much data, that's a physical box that'll come to your office, you'll fill it up with data, you'll send it to AWS, and now it's up in AWS. I could do, storage gateway is a great solution for these people. There's a lot of different ways that you can throw stuff. I'm not going to go into every single one of these, I'm just showing, I wanted to have the visual here that there are a lot of different ways, from a file-based, from a database, and then you have the things that you've heard some about today in terms of, they're not really necessarily storage, but they work in the manipulation of and the querying of and the access to your storage. And again, this is not a complete list. The bottom line is there are a lot of ways that you can store data in AWS. It pays to know your options. Now, how do we protect it? So when it comes down to it, the first thing you need to think about is architecture. The way your network is laid out. If you're leveraging a service at AWS that can use the concept of a virtual private cloud, a VPC, that VPC defines the security border around the things that you have in the cloud. And you can do it right, or you can do it easy. I mean, in reality, doing it right can be easy as well, but it takes some knowledge. You need to make sure that when you lay out your subnets, that you know where your private data is and your public data is. And again, I'm not going to be able to go deeply into it. I could do an entire session on VPC architecture. But what it comes down to is if you were to stand up an EC2 instance, a server in the cloud, you've got, theoretically, all of these different layers that you need to think about in terms of why can I or can I not get to that data. You might have a WAF in front of an application that's fronted by a CDN, a content distribution network, and then you have a firewall. I didn't even throw ELB, I left it off, sorry. You might have a load balancer in there too. Then you have a gateway that protects your public from your private, and you have network access control lists. You might not even get to the network access control lists if your route tables don't allow your next hop to be defined as something that goes across a subnet barrier. And then you have security groups, which are basically AWS's panacea answer to routing-based security, security between components. I'm going to talk a bit more about that at some point. But then you get down to the OS firewall, which if you'd like to, I'm a Linux guy, I want to put my IP tables on there. You can do that too. And it's great. You can have the most secure brick of stuff you can't get to in the world because all of these different layers need to be configured just right to let things through. Or you can go the other route and leave it wide open, and now the bad guys are in your pants, and you've got nothing you can do about it. So your architecture requires some thought. Most of AWS's built-in services these days can leverage the VPC constructs. When you're using something even like S3, for instance, which is a public-facing service, one of the oldest of AWS's service, there are concepts of VPC endpoints, so that when you access things from inside your virtual private cloud, you don't have to go over the internet to get to it. You can leverage AWS's private backbone and use some security around that. So that's the longest one. I think it gets easier from here. Key management. So now, encryption at rest. That's one of the original rallying cries of the security industry. Right? If your data is not moving, it should be encrypted. It's a simple concept, but it's not something that a lot of people can comprehend or know what to do with. AWS has the Key Management Service. The Key Management Service allows you to centralize the management of those private keys that you use to encrypt your data. It is built in to a lot of services. If you want to encrypt your data on S3, it's an option. And you can use the built-in AWS S3 automatically generated key that's in Key Management Service. And many other services have the same kind of checkbox. You're encrypted, you're good to go. But a lot of companies aren't comfortable with that. So you can generate your own keys. Bring them with you. You can even, if you're one of these heavily regulated industry folks, you can get your own HSM, which is a hardware security module, which is in reality a piece of hardware sitting in the AWS data centers that is yours, that holds your keys and your encryption. So there are a lot of options using KMS. The thing that I like the best about KMS is that you can configure this with the same methods that you use to stand up your systems. And I'm talking about infrastructure as code. If I'm using CloudFormation or Terraform or Pulumi or whatever the flavor of the month is for whatever it is that I'm deploying from an infrastructure as code standpoint, it's a few more lines and I can generate a key and I can then encrypt my things. So if you're not doing it, you really need to look at why. It's compatible with most of the data structures. Oh, and then very importantly, you using IAM, which we're about to talk about, you define who and what is allowed to use a key. It's great to be encrypted, but if you're encrypted and everybody knows the key, then you're not encrypted because everybody can just decrypt it, right? So what you do is you define who is allowed to use the key, and you can be stingy with it. You could say my production workload is the only thing that's allowed to access, to use, to decrypt with this key. And therefore, I know that my dev workload isn't going to accidentally be able to do anything in production. All right, and I have a case about that later on. Now, encryption in transit. So certificates. From a encrypt all the things standpoint, we're in that world now. It used to be a sort of expensive thing to do to encrypt your traffic as it moves. It is not anymore. There are free and cheap services that will generate certificates for you, and you can use them, and you can bring them, and you can upload them into IAM, and you can use them to encrypt things. AWS has made it even easier. If you're using a built-in AWS component like load balancing, you can use the Amazon Certificate Manager and generate public certs for free. Okay, as long as the only trick is you don't get the private key. You can't export it from there and then go and use it on Google's cloud platform. I don't like saying the Microsoft, the A word. But you can apply it to API gateways, load balancers, and literally any other service that supports the configuration of certificates of web traffic via an API. So it's great. Now, if you still want to use ACM, you can also have it generate private, it can be a private certificate authority for you, and issue private certs that are just for your enterprise environment, whatever it is that you're doing. You keep the key. You can use those certs any way you want. Nominal cost, $400 a month, and like a few pennies per cert. But if you're doing something that's generating a lot of traffic, generating a lot of connections, and you need to encrypt them all, why not? That's not too bad. So that's key management. IAM. So I didn't pay him to say it, but Steve, who came up before me, did a great job of pointing out that when you see the asterisk in an IAM policy, you need to question it, okay? In his example, he had resources star. His policy he was putting in was a built-in policy, and it was granting permissions to all resources using that policy. And that's fine for a built-in generic policy, but when you're permissioning your things, you're going to be creating policies that need to be specific, be explicit. Grant permissions to the people to do things, to do just the right things on the right resources. If you can get to this point and you can do this by default, you're going to be a lot happier with your security footprint in the end. So let's go back a little bit, a step, and talk about it. So this is how you restrict and allow access to different services. It is another one of these topics that is complex and deep, and you can go very far into how to configure IAM. It has a syntax of its own that is, excuse me, that is not, to the novice, is not easy to comprehend, but once you get it, and you can do a lot of good things with it. So, avoid the demon star, all right? Least privileges has to be the way you go, all right? Whenever possible, you want to permission things using roles instead of users. The days of, well, my application has a config with a username stored in it somewhere, and I have to go get that and use it, and it sits in a flat file on my operating system so that I can connect to my database. Well, that's just a honeypot waiting for somebody to come and get it. All right? If you use roles, you can say that the machine that's trying to access my database is allowed to access the database because it's that machine. All right? You can grant that role at the service level. So that's another one that, again, being a traditional security guy, as I was at one point in my life, you need to comprehend that user management isn't exactly, you can be the best at managing user and password credentials, but it still might not be your best answer because using a role is going to be better. And then you don't have to store the passwords. Also, when you're permissioning things, use groups. That's an age-old one. You know, if every user you've got or every role you have in your environment has an individual different set of permissions applied to it, it's a management nightmare. Use groups, so it's sort of you get towards role-based access control. When you're trying to figure out what permissions to grant to something, that can be particularly challenging. I'm trying to stand up a service and I'm getting a permission denied error. How do I know what's wrong? Okay, well, if you're like 99.9% of the world, you're just like, screw it, give them all. And you give them the demon star, and you end up in a situation where you don't know what your app is really doing. So you can use CloudTrail, which is the log of all of the API activities that have occurred, most of the API activities that have occurred, and it can tell you you're getting denied trying to do Dynamo list objects. It'll tell you the exact thing you need to give permission to, okay? And again, I wish I had more time to go deeper into it, but just if you ever come back and look at this chart, hopefully you'll see this and say, that makes sense. Okay, the other thing, when you're doing IAM, because of the fact that it's so complex, do it in code. Use your CloudFormation. If you're going into AWS and configuring things by hand, you need to start having that guilty feeling, okay? Because you're not going to do it the same way twice. Your dev environment will not be just like your test environment or your prod environment. You need to be in infrastructure as code, okay? CloudFormation is extremely easy once you get into it. You just have to force yourself to get into it. I have people in the room right now who know this wholeheartedly, it wasn't until you actually started doing it that you realize it makes you understand things better and it makes things repeatable. So IAM is particularly good for that, especially because there are linters and nags that can show you, hey, you're about to make a policy that's way too open. It will pop up and say, why do you have a star in your resources here? It's a great reminder. We all need reminders from time to stay on the right path. Code reviews, all about it. And again, I can and have done entire presentations on the values of infrastructure as code. And you can include your security people when you're making changes to things. We should want that. All right, continuing in identity and access management. When you're configuring your account, I'm going to move through this pretty quickly. This is some basic core AWS stuff. Your security policy in your account, when you set up your account where whatever you're doing, where your workloads live, require MFA on all your users. Enforce password complexity, enforce password expiration, rotate the keys. I love going into a customer's account and seeing, key was issued 685 days ago. Like, really? What we're trying to get at here, and you might say, why is this in about securing the data? Fact of the matter is, if your environment is easy to get into because your security policies are weak, your data is not secure, no matter how much of the other things that we talk about happen. You can be encrypted at rest, you can be encrypted in transit, but you have a stupid policy that lets people get in, you're in a situation where you're just kind of leaving the front door to the prison open. So, yeah, on your root accounts, make sure you enable MFA also. And don't lie. Oh, I forgot to put that up there. Oh, yeah, I did. Yeah, never use your root account. If you're new to AWS, that might be a weird thing, but never use your root account. Change the password to something ridiculous, get a physical MFA token, put it in a vault, never use it. Because if somebody gets those credentials and gets in with that account, they can do literally anything. They have pure God rights in your account. Make an IAM user and use that. Okay, making things public in AWS is okay, as long as you know that it happened, okay? This is key. And I'm going to talk a little bit, if I get to at the end here, if I get to it, we'll talk about the fact that not every breach of AWS is AWS's fault. You can make things public. That's part of the benefit. It's a web service. It's for public consumption. It's okay to make things public if that's what you intend to have done. Just be aware and be careful. Managing secrets. Again, still in the spirit of if people get the password, encryption doesn't matter. If the key is known, encryption doesn't matter. Store your secrets in vaults. All right, I'm not talking now about the actual operation of your environment per se. I'm talking about the management of your environment. If you're doing things, deploying, if your application needs to pass secrets to each other, if it needs to authenticate, store your secrets in vaults. Okay, encrypted, like Amazon has Secrets Manager. If you don't want to use Secrets Manager, that's fine. I threw Thycotic Secret Server up there just because they've gotten a big foothold lately in the customers that I've seen. It's an on-prem or cloud-based secret manager. You can use the vaults that come with a lot of different vendors. HashiCorp has one, Ansible has one, Kubernetes has a vault. There's vaults everywhere. Make sure you're storing your passwords encrypted and you're protecting them appropriately. While we're at it, your parameters, you can programmatically access those as well. I'm a huge fan of Amazon's Systems Manager, SSM parameter store. When you're deploying things, keep all your variables there. Keep your code in a code repository, Git, whatever. You can also throw your secrets and your parameters into S3. Nothing wrong with that. Throw them into a file, put it out there, encrypt it, and protect the hell out of it. But that's you manually having to do that as opposed to just putting it in a secret store whose job it is to encrypt and protect these kinds of things. And yeah, no, please never put passwords in your source code repository. And I mean anything secret. I'm talking anything secret does not belong in Git. Because people are looking. There are scanners, there are open source projects that are built around, hey, let's go find what people have stored AWS secrets in GitHub, for instance. And I'm picking on Git just because it's popular. Okay, now, how you store things is kind of important. General tips, blast radius. You need to make sure that where your production data is stored is a protected area, and protected in that it's isolated from your other environments. You don't want somebody who gets into your dev environment and can then pivot into your production environment. Go multi-account. Don't put production in the same account as your development. That way you have full-on separation of duties there. You need to make sure that these operational things are active decisions that you can make. It used to be that it was troublesome and heavy to manage multiple AWS accounts. It is not anymore. Multiple AWS accounts is easy. Make sure that if you're replicating your data, that you replicate your security as well, right? You need to make sure that just the right people can get to that data. If you're using your replication to populate your UAT environment, sanitize the data. You don't want any PII or PHI or whatever your protected information may be getting into those environments. By the way, you can automate all of that with data pipeline. You can create data pipelines that will extract data. It's an ETL tool. It'll extract data, transform it, and then load it into another environment for you. Pretty cool. And Athena, I love Athena. Athena's awesome. But you have to make sure that when you're permissioning it and Glue and the other new sort of meta layer of query tools for AWS to query itself are configured in such a way that you're not necessarily giving your reporting people access directly to production data unless that's what they need. This is the age-old thing of make sure you know who you're giving what access to. I feel really bad that I'm going this fast, but I think we're getting close. Yeah. Logging. Do it, protect it. Are these charts going to be available for folks, by the way? Okay, so just very quickly, CloudTrail, I mentioned before, it's a log of everything that you've done to AWS. Make sure you have to turn it on. It's not on by default. Turn it on. CloudWatch Logs gives you a place to store your logs. If you don't know where to log things, log it there. And SIEM in general as a concept, if your security team has a SIEM, make sure your data is getting to them. If they don't, offer to stand them one up because there's a lot of great options in AWS and in the cloud in general. Now, I wanted to get to this, a couple of real cases. The GitHub oopsie. Unfortunately, this actually happened to somebody on my team. I had to help clean it up. There was a new DevOps employee at a customer. They wanted to practice at home. They had great intentions. So they committed their working branch of their infrastructure as code to their public GitHub repo so they could go get it from there. What they didn't understand is they pushed their secret key, their AWS secret. You know, when you get CLI access to AWS, you get access key and secret key. That secret means something. That's a password. They put it in there, in their GitHub repo. The next day, I think it was something on the order of $80,000 of services had been spent globally of a Monero miner, which is like Bitcoin, a crypto miner, was installed in all of their non-production regions. And yeah, no, they weren't very happy, and they didn't even understand what was happening at first. By the way, that's another lesson to take away from this. First of all, train your people. But, and I neglected to put it here, remember, AWS is global. And when you're taking an action in one region, you need to be aware that there are tens of regions around the world where things aren't even going to be showing up on your dashboard unless you manually change to it. If you're in US East 1, Northern Virginia, and somebody's in your account doing things in the the Asia Pacific Southeast, you're not going to get alerted of that. So you need to make sure that you either disable those, which, thank you AWS, they've made that a checkbox that's not obvious to find. It's in your security options. Uncheck those regions to say that you're not allowed to use them. Or write yourself a script that says any API behavior, CloudTrail, that happens in another region gets logged and alerts you. Okay? I wish this wasn't real world. It is, and sadly, you know, it costs money. So, I have a second to do a couple real quick. 1 second. Okay, I'm going to skip this one, and we're going to go to the S3 bucket policy. Just I mentioned it before. AWS had another breach, and all my data was lost. No, AWS didn't have a breach. The administrator, they've made it at AWS so hard to make things public anymore. That's because it used to be so easy, and that's when a lot of these problems where people were, you know, putting on a bucket policy that said allow anyone in, and suddenly the one person they wanted to share it with is able to get into their data, and they're like, yay, I did it! Well, you just let the whole world in there too, and that's where a lot of these large chunks of data are taken from. Thankfully, it's become way, way, way harder to do that. When you have a public bucket, a big pop-up comes up and it says, did you know everyone in the world can see this? And there's flags and there's colors, and it's getting easier, yet people still keep doing it because people are people. So make sure that you're watching for this, okay? That's the only thing I can say. That's the only thing you can do. Train people, make sure they don't do stupid things. And I think that's all I've got. I want to put a plug real quick. I also, with Jeremy, who's back there, we run the Greater Philadelphia AWS user group. We meet every month, sometimes more than once a month, on varying topics of varying levels, from beginner all the way through to expert. Keith, who's been presenting a bunch here, is one of our best presenters that we've got as well. And we try to keep it diverse, fun, and we take recommendations. So go to meetup.com, GPAWSUG, Greater Philadelphia AWS User Group. If you have questions about it, let me know. It doesn't cost you anything except your time. We usually meet out in Bluebell or King of Prussia. We are open to anywhere. We just don't like paying money for things. So if you have a free spot, we're in. So, thank you.